Okay. It's our pleasure to have Carlos Castillo, better known as Chato, as a guest speaker today as part of the Tiger Talk series. So Chato is a distinguished professor in Universitat Pompeu Fabra, which is a Spanish university, or to be fair, a Catalan university based in Barcelona. And before Pompeu Fabra, Chato was a research scientist in Qatar Computing Research Institute. And before that, we spent several years in Yahoo Labs in Spain. The main research area of Chato is the web, which is quite broad. I think he started with web crawling and then moved to web search and then web mining. And in more recent years, he worked on the social aspects of the web, like influence propagation and disaster management in social media. And more recently, he's working on fairness, accountability, and transparency. He published more than 80 papers in top information retrieval and data mining venues, and he won 6 Best Paper Awards, which is an incredible achievement. He published a book on big crisis data, not big data crisis, big crisis data, published by University of Cambridge. He also published several short papers, monographs. So he's a very well-known researcher in this area. Again, it's my pleasure to have Carlos Castillo today with us giving this talk. So I'll leave the floor to Chato.
Mm-hmm. Thank you very much, Barla, for the introduction. I shared my slide with Barla before the presentation so that he knew what the topic was about. I guess for some people, it will be the first exposure to fairness in ranking topics. For other people, this will be maybe a repetition of things they know, but perhaps it will also be interesting to have a discussion about this. So I hope you will enjoy this talk. So today I'm going to talk about algorithmic bias in rankings. I'm in slide number 2. If you cannot see it, please let me know. So our first question will be whether algorithms can discriminate, and we will go to some definition from model philosophy to try to uncover that. Then we will speak about algorithmic fairness in information retrieval, then about how to measure or detect that the ranking doesn't have some algorithmic fairness properties. Then we'll speak about creating fair rankings, and if the time allows, we will try to talk a little bit about transparency in rankings. So let's start with this question of whether algorithms can discriminate. I think I'm starting with this definition from the book Born Free and Equal, which speaks about what discrimination is. Right? And generative discrimination requires an agent that discriminates against someone in relation to somebody else. Right? So X discriminates against Y in relation to zeta. So and the discrimination is simply to treat someone differently in a way that is disadvantageous, right? So it's disadvantageous differential treatment. And we all discriminate all the time. So if you're doing job interviews, if you're interviewing people for a position, basically your task is to discriminate, to treat someone in an advantageous way with respect to somebody else because that person has a certain property, right? So discriminating is a very natural operation. It's something we do all the time. And in principle, there is nothing morally wrong, objectionably from just discriminating, right? This genetic discrimination in this specific sense. But then there is group discrimination, and group discrimination is to give a disadvantageous differential treatment to someone because that person belongs to a socially salient group, right? So, or in relation to that person belonging to a socially salient group. A socially salient group is a group that you belong to that is very visible and that impacts, normally that impacts your relationships in society, particularly relationships of power. So, for instance, your gender or your age or your nationality may be considered a socially salient characteristic of you. And then if you are treated differently from somebody else because of the property or belonging to this socially salient group, you can be told to have been group discriminated, right? So there is group discrimination is defined in this particular way. Then a particular form of group discrimination is called statistical discrimination. So statistical discrimination is group discrimination based on a statistical belief. So if you treat if you treat a person worse than another person because this person belongs to a socially salient group, and because you have a statistical belief or evidence from the past that supports this differential treatment, then you are engaged in a statistical discrimination. So the typical example of what's a statistical discrimination versus non-statistical discrimination will be the following. So if you desire to not hire a highly qualified woman because you believe that women have a higher probability of taking parental leave based on your previous experience, then you are engaged in a statistical discrimination. You are treating a person worse than another based on a statistical belief. So on the other hand, if you decide not to hire this highly qualified woman because she has said that she intends to take parental leave, then this will not be, there will be non-statistical discrimination. So in statistical machine learning, I claim, and other people will also probably support this claim, that an algorithm developed through statistical machine learning can statistically discriminate. We just need to take a couple of elements out of the standard definition. First, we need to disregard intentions or animosity, right? So we don't need to associate to the algorithm a certain intention to harm people from a certain group. However, that's also problematic because we don't know about the intentions of the developer. I mean, somehow you may have like a cybersecurity issue, a computer security issue here, which is the fact that we don't have a way of protecting ourselves against an attack from a developer. But for now, we say let's disregard all these intentions or animosity. And second, we understand that the statistically relevant or it's a statistical belief are anything that the machine learning algorithm picked, right? So that's the purpose of a statistical machine learning algorithm, is to pick statistically relevant facts to discriminate between two classes or more, right? Or to do some inference. So in this slide, we can say algorithmic discriminate, how an algorithm can engage in a statistical discrimination or statistical group discrimination. So let's talk now about algorithmic fairness in information retrieval, right? So typically, ranking in information retrieval has had this objective of providing the maximum relevance to the person who is issuing a search, right? So which means that the best way of ranking a list of results will be by decreasing probability of those results being relevant, right? However, increasingly, we have started to rank items that have their own interests. Like they are not just objects, right? So they have their own interests. So we have started to care about those items being searched. What do I mean by this? So sometimes it's not just a matter of providing the maximum utility for the person issuing the search. It's also important to provide some utility to the objects being searched. So if you are trying to find a local business, then you are impacting the business success of those business that you are searching for. If you're trying to recruit a candidate for a job, then by ranking these candidates, the system is impacting the career success of those people. If you're learning about a political candidate and you have the political success or the voting of these candidates, and even you could consider that dating apps are also a form of a recommender system, but they also rank people. And in recommender systems, we have similar issues to the ones I will describe today. And so these can affect indeed their affective success or even their reproductive success. So fairness for those people searched, I will say it's related to at least these three elements, right? So first, the ranking should provide a sufficient presence of people in the protected group. And here we use a definition from a previous definition from algorithmic fairness in data mining, which separates people into people who are protected and people who are privileged. And the focus of algorithmic fairness methods is typically on ensuring that the protected groups receives utility, exposure, whatever, that is comparable to the one of the privileged group, right? So this sufficient presence of elements of the protected group should lead to an absence of a statistical group discrimination or to mitigate the statistical group discrimination and prevent like economic harms, right? Distributional harms. A second element of this fairness for those people who are being searched is to ensure that there is a consistent treatment of people in both groups, right? So there is a consistent treatment of individuals. And this is this is connected to an element, again, from the data mining literature in algorithmic fairness, which is individual discrimination, which is basically inconsistency, right? You expect that two items or two individuals or two business that are very similar to each other should be similarly ranked. Third, there's something a bit harder, more difficult to define, which is a proper representation. I will speak about this, and the idea is to prevent representational harms. Then from the side of the people who are searching, you can also think that there are certain issues that are related to discrimination or fairness, right? So we ideally would like to have that different groups of people searching should experience a similar level of satisfaction with the search engine, right? And there are indeed like some studies that show that, for instance, similar queries posted by a younger person or an older person should have different results. And if somehow your training, your machine, your ranking is optimized to provide a good ranking for a certain group of people, it may provide a ranking of lower relevance for people from another group, right? So this is coming back to people who are issuing these searches. Now, as I said before, representational harms are perhaps one of the most difficult to define, and they have to do with how a system may reinforce the subordination of a group to another. And there is an entire book about this called Algorithmics of Oppression by Safiya Noble, based on an observation she made around 2013, where she saw that in Google, in the image search results, if you search for Black women, you will get highly sexualized search results. And indeed, if you search for anything like Japanese women, German women, and so on, but if you issue a similar search for Black men or Japanese men, you will see a much more diverse set of photos, right? And this is something that today doesn't happen. So if you search for Black women today in Google search engine, you will see heavily curated results that have that include a variety of themes about women, right? There are also stereotype search suggestions. So somehow Google is no longer auto-completing nationality R searches for many nationalities, and when they do, it tends to be very curated, right? They in some cases they just don't show any results. In other cases, they show results that look quite positive and quite strange as search queries. So they have somehow blacklisted these things, and of course you have automatic tagging errors that may tag a person with the name with a person as a gorilla or whatever. Like they help like represent a certain group in a bad light, or in a way that reinforces this subordination. There is another example. This is an older example, which is what happens if you search for professional hair for work or unprofessional hair for work, or hairstyles. And you will see here that if you search for unprofessional hairstyle for work, you see a majority of Black women, and if you see professional hairstyle for work, it's a majority of white women. Of course, we don't claim these things are intentional. We just say that they are producing a representational harm to a certain group. Now, we also mentioned, like, among the criteria, this one that I'm going to talk more about this, which is about what is a sufficient presence of a group, right? So here are 3 search queries done against a recruiting website, which is called Ching. It's similar to LinkedIn, and is used substantially in Germany and Austria. And if you search for economists, for instance, you will find that the first result is a woman, and results 2 to 10 are men when we did this query, right? So if you look at the top 10, men are 90%. Now, if you go deeper in this list, you find that men are actually 73%. We don't know how deep you can go in this list, but the representation of women in the top 10 results is smaller than the representation of women in the top 40 results. Market analyst is a case where the opposite happens, right? So you see 80% of women in the top 10 positions. However, if you go to the top 40 position, they are just under 60%, and so on, right? So there is, I would say, in many cases, the share of the minority group, be it men or women, in the top positions is similar to the representation in the top 40 position. However, there are some cases where you see these deviations, and these are difficult to, first, I think they are a matter of concern. And second, they are difficult to evaluate, because you can also say, well, it's true that if I search for an economist, there is only one woman among the top 10 economists that the search engine retrieves. However, that woman is in the first position, which is a very important position. It's not the same as if she were in the 10th position. So how do we compare like a woman in the first position versus two women in position number 4 and 7 is something I will talk about in a moment. So there is this is another example, which is taken from Amazon and Book Crossing, and this is about like what do you see in ratings and recommendations for certain people, and you see that like these lists of authors that are liked by some people, they sometimes they have like for instance 0% of women, and there is a certain distribution of this of, let's say, the gender diversity of this list, which impacts also the recommendation. In some cases, like this is a more general observation, in some cases what we have seen is that some systems, when there is some degree of bias in the input data, be it like, for instance, user preferences, many systems some systems tend to exaggerate these differences, right? So they are not just merely reflecting what you see in these users, but sometimes they exaggerate these differences. So here at this point, I need to mention that there are two completely different goals in people who have looked at these problems and have tried to mitigate them. And these different goals, I will describe them as reducing discrimination and providing equal opportunity. By reducing discrimination is really looking at detecting cases where you have people from a protected group or a marginalized group or a minority group that could provide higher utility for the people who are searching, but somehow you are ranking them lower because of some reason, right? So let me give you an example. We have seen, and we are not the only ones who have made this observation, that there are some standardized tests that are applied for entry to universities that tend to give lower scores to economically disadvantaged applicants. However, when those applicants are admitted, they have better academic performance, which means they have, for instance, larger probability of finishing the grade, and perhaps they have better grades on the first year, right? So these are the types of observations that people make to claim that they have better academic performance. So here, like ranking these people from the protected, marginalized minority group higher will help both the people in that group, but will also help the people who are searching, in this case, the university, right? So this is a kind of an easy, like this is kind of the simpler case. You have higher utility, lower ranking for a protected group. However, in other cases, you want to do something else, which is you have a protected group that has lower utility, but also has lower rankings. So for instance, in the case of university admissions, you could have a group that has both a lower score in their admission test, but also they have poorer grades when they are in the university and perhaps a smaller chance of getting, of graduating, right? So in this case, you have a protected group that has lower utility and has somehow lower rankings. Now, if you decide to increase the ranking for this protected group to give them more exposure, then you will harm the utility for the people who are issuing the search. But there are situations in which you may want to do it because you want to correct a historical disadvantage, or because you want to increase the representation of people from that group in your university, in your pool of applicants, or there may be external factors that make you want to kind of go against that utility and increase the representation of people in the protected group. But if you do it, I would say what you're trying to do is to provide equal opportunity. Like this is the goal that you're addressing, and not so much reducing discrimination. And this, of course, these concepts are difficult to define, but I go to this book by John Romer called Equality of Opportunity, where he also describes like these things as very, very clearly different. So it's very difficult to make a case to create fair rankings in the second case, right? So in some cases you have if you work for a search engine or your recommender system, you build a recommender system, and you find that there is some bias or some discrimination that is harming the searchers, then it's very easy to do these changes. Like in other cases, you may have legal mandates, like for instance, you need to include a certain proportion of people with a disability in your ranking for candidates, or you have a voluntary commitment. You say, well, I want my list to show an equal number of men and women, or a similar number of men and women, and then you may be mandated to provide equal opportunity. And in other cases, and this is perhaps the most difficult case, you have certain values, certain moral values, and you want technology to embody those values, and that's a difficult thing to sell, because you need to convince other people that these are the values that your company, university, organization wants to promote. Now, in many cases, I would say that this is perhaps the most direct, the most obvious case. There are biases in the input data, and these biases in the input data, they are the main cause of algorithmic discrimination. So you may have biases in the training data that experts provide, expert annotators. You may have a pool of expert annotators that is not diverse enough, or that it's biased to a certain age group or to a certain gender. And we see from previous research that relevance depends on the group you belong to, right? So you may have your editorial team biasing your ranking. You can also have biases in user-provided training data, which are more difficult to handle. So, for instance, there is now one of the earliest works on algorithmic discrimination in search was with respect to advertising. And in this work, what authors did was to take two instrumented browsers and navigate the web through the same web pages, and then create a profile in Google in which this profile was labeled as a man or as a woman, and then issue the query jobs. And what was the result of this was that if you mark in your profile at that point, if you marked in your profile that you were a woman, then Google will show you less ads from the category of ads of high-paying jobs. And one conjecture was that this was because women will not click on those ads. So in somehow your users are giving you training data that is biased, right? They are giving you feedback that is biased, and you may or may not want to correct this bias. So for instance, you may have a rule that says, I would like to provide equal treatment for men and women independently on whether they click different. And third, there is a bias. There may be biases in the document construction, in the way in which the documents are constructed, which is even more difficult to manage. So, for instance, there are some works that show that there is a work that shows that if you look at LinkedIn profiles for men and women from elite universities, you will find some differences in the way in which they complete their profiles. And the stereotypical difference will be that men will provide many details on their past experience, while women will provide many details about their skills. So if there is this difference, even if the difference is not so large, you may imagine that a system that tries to rank these documents may be ranking documents from men or from women differently, depending on the emphasis it gives to, for instance, matching of these terms against past experience or past skills. So there may be biases, again, in the expert-provided, user-provided data, or in the document themselves. So, so far, so good?
Yes. There's a discussion going on about some more to completion in the chat, but I don't think it's just a side discussion. So yeah, so far so good. Thank you.
Great. So let me talk now about measuring these rankings, right? So let's try to evaluate a ranking from this perspective of how, basically the perspective will be how much exposure or how much, trying to quantify trying to provide a measure for this sufficient presence of people from the protected, marginalized, or minority group, right? And there are basically methods based on exposure and methods based on probability for this. And the methods based on exposure are perhaps easier to grasp. So basically, you have from eye tracking experiments this result that you have a certain probability of examining a certain document. And they will consider a disparate exposure measure will consider that the ranking is fair if the exposure is given to, the average exposure is given to people in the protected and non-protected group is similar, right? Then and this is very tricky to achieve. Look, let me give you an example. So suppose you have done a standardized test. You're hiring people to to transcribe documents, and you gave them a test in which you measure their typing speed, and these were the results of the test. And the 3 male candidates, they get this score. The 3 female candidates get these scores. Now, if you sort them by relevance, what you have as a result is that of course, the 3 men, in this case, the 3 men candidates are at the top because they have a slightly higher score in this particular test, but their exposure is vastly different, because if you discount exposure by, for instance, logarithmic, which is one of the typical ways of discounting in search, then you will find that here you have a very small difference in average relevance, but you have a much larger difference in the exposure you are giving to these 2 groups. And the claim of these authors is that in this case, what you should do is to re-rank these elements in such a way that the exposure given to men and women is proportional to the relevance of those groups, right? And this is what they call like a utility normalized exposure, right? So you have the exposure divided by the utility of people in that group. You're not completely ignoring relevance, but you're saying overall, I should rank the list from most relevant to least relevant, but I should ensure that the exposure I'm giving to each group is proportional to the utility that group provides for the searches, right? And I should not leave the discounting exposure by the positional bias to distort the exposure of this group so much, right? So there are other methods that are based on estimate on probabilities, and they start from like an idealized merging of lists, right? So suppose you have a search engine and you are ranking men and women in a list, and somehow what you do is that you rank them separately, right? So you decide to find the best method to order men, the best method to order women, and now you want to mix them in a way that doesn't take into account their utility, but just ensures that there is like a mixture of men and women in the ranking. And you can do this with a kind of a randomized merging. And with this randomized merging, what you do is that with a probability P, you pick an element, a woman, and a protected element. With probability 1 minus P, you pick a privileged element, right? In this case, like this, for instance, the third will be an idealized realization of this process with P equals 0.5, right? So you have an interleaved list. Of course, you can have other things, but so based on this process, you could define a fair representation condition, and this fair representation condition will be that will be based on a binomial test. Basically, you will say, I want to make sure that if I have a list of a certain size, and you tell me that this list contains a proportion P, or was provided by a randomized merging with a certain probability P of a protected element, then I will tell you whether this is consistent with that hypothesis, right? Based on a binomial test and a certain significance for this binomial test. Now, so for instance, here are some examples of this binomial test, which is not interesting. What's interesting is that from this, the problem is that when you're dealing with a ranking, you're not dealing with a set. And one of the problems of a ranking is that you don't know at which point the person who is searching is going to stop. So maybe you have a sufficient presence of elements from the protected group in this ranking, but they are at the bottom. So some of the searchers see these elements, others don't. So what one could do is to say, well, the criterion should be that for every prefix of the list, that set should comply with the fair representation condition, should satisfy the fair representation condition. The problem there is that you do multiple hypothesis testing, because you're checking the list against many you're testing the list many times, so you have a higher chance of rejecting actually, let's say, a ranking that satisfies the conditions. So there is some need to do some adjustment in this case. But the final result is more or less the same, right? So you have a list, you compute prefixes from this list, and then you check if every prefix of this list will satisfy this criterion of having a sufficient representation of people from the protected group. So this is useful because it allows you to compare lists of different lengths coming from different places, right? So for instance, here we have some results of applying this to job search. And here what we did was to take Spain, France, and the UK, and to take a series of possible professions or occupations and look for look for the result list and check with what probability is this compatible, right? With what merging probability is this list compatible? Of course, a higher number will mean, in this case, more women, and a lower number will mean less women, right? And we observe, this allows us to observe differences, for instance, between countries, which are expected because there are some countries in which the representation of women in the workforce is smaller than other countries, even within Europe. But also it allows us to see difference between search engines, right? So you can have the same profession search in two different candidate search engines or career search engines, and you will find very different proportions of women and men in those cases. More worryingly, and this is perhaps maybe clearer for people who speak a language with gender in professions like Spanish, Italian, or some Romance languages they have. Even German has a difference for this, like and other languages, was that there is an inconsistent treatment of the masculine as neutral, right? So there are some search engines, some search engines and some professions in which if you search for the male version, let's say profesor, then it returns both men and women, profesor and profesora. However, there are other cases where if you search for the male name of the profession, then you only get men. And if you want women, you have to search explicitly for women. And this is not consistent within a search engine, and it's not consistent. It's not even consistent within a search engine, right? So you have having the same search engines, two professions. In one case, you have to enter the masculine is neutral. In another profession, the masculine refers to men. This also has to do with changes in the language, I have to say, right? So for instance, when I learned Spanish, which is my native language, a female doctor will be médico, which ends with an O, which marked it as masculine. But I would say five years ago, the Royal Academy of Spanish allowed, or said that the correct word was to say médica, which is a strange word for me, but it is the way in which the language is constructed now. So there are changes in the language that and search engines are not catching up with those changes and lead to these weird inconsistencies, even within the same search engine. So I will speak briefly about creating these FAIR rankings. So there are basically three opportunities for trying to mitigate any issue of algorithmic fairness, and these are typically called pre-processing, in-processing, and post-processing. You either change the training data, you change the algorithm, or you change the results and re-rank things to match some criteria, to satisfy a criteria. Post-processing methods were the first to be proposed in data mining, and they are among the first to be proposed in ranking, right? And they have basically deal with applying certain constraints to the ranking at certain positions. These constraints may come from a probabilistic test, or they may be externally defined, but are basically like a matrix of constraints that you have to satisfy and that forces you to re-rank elements. These are the easier to define, and they are, they have been discussed extensively in the literature. So there are other criteria for re-ranking that are more probabilistic, and they seek to maximize a certain element. Like, for instance, they seek to minimize the difference in utility normalized exposure. And they, again, lead to a re-ranking of elements that satisfy a certain condition. This is all post-processing methods. Another post-processing method that I find quite interesting is called this method based on amortized fairness, which says that you cannot expect to satisfy one of these criteria for every search, and maybe even that will be disadvantages for your users. So what you want to do instead, or you may want to do instead, is to take a set of queries or a large set of queries and ensure that these exposure ratios are, let's say, similar, or this utility normalized exposure is similar between groups, but in an amortized manner. So if you take on average many queries. So then you have in-processing methods. So in-processing methods, what they do is that they try to modify the objective of the ranker. So in this case, you can have, for instance, a learning to rank method. In traditional learning to rank, what you have is that you have your training data and you want to minimize a certain loss, which is the difference between the ranking that your learned ranking will give to elements in the training data and the ranking that those elements actually have there. Well, here you can add, and this is what has been done by several authors, like you can add a penalization. This is also done in supervised learning classification, not only for ranking, also for supervised, not only for ranking, also for classification. You do similar things. You add a penalization term, and this penalization can penalize, for instance, different exposure, right? So there are also pairwise learning to rank methods where you can, again, like introduce some penalization or measure things in a different way to ensure that the learning to rank gives you similar levels of, for instance, engagement or relevance, or engagement as a proxy for relevance for protected and non-protected elements. And you have pre-processing methods which are not really very common, which in ranking yet, which what they aim is to either modify the training data or represent them in a different way. Like in this case, you have perhaps one very interesting approach to this problem is to try to learn, is to take your training data and transform your training data in a way that mixes protected and non-protected elements according to the attributes with minimal distortions, and then learn your ranker or your classifier on the data that has been transformed in such a way that you can no longer distinguish who is a man or who is a woman or who is from protected group and who isn't. So we finished the last section with transparency, speaking a bit about transparency in rankings. So transparency is this idea that you communicate to people why a certain ranking is produced in a certain way, right? Explanations allowed us to implement certain objectives, to make these trade-offs visible, because you may have to trade utility for fairness in many cases. And ideally, I would say a good explanation is one that empowers users to challenge a ranking, empowers a business to say, your search engine for business is mistakenly ranking my business in the wrong place because of this and that, right? So it allows you to challenge these rankings. So as a side note, I would say that advertising transparency, which is one of the major issues of transparency in search engine, has become less transparent over the years, right? So what I mean by that is that if you remember Google circa 2007, then advertising was very clearly labeled and quite separated from organic search results. Today, I will say that this is not the case. Like there is much less, it's very similar to how it was in 2017. There is a very small marker distinguishing advertising from search, from organic search results, right? And then there is Donald Trump. And there is this claim, as many of these claims, completely unsubstantiated, but this is a very difficult claim because he says, okay, Google is actually penalizing conservative media, and it's ranking, it's pushing up ranking by liberal media. And the problem with this statement from Trump is that there is no way we can prove him wrong here, right? It's very difficult to prove him wrong. There are other issues in which we can prove him wrong, with respect to vaccines and other things, and coronavirus, and you name it. There are many issues, but this one, it's very difficult to prove him wrong. I would say we don't have the tools, and anything short of an audit of that ranking, similar to a financial audit of a company, will not satisfy, will not provide a satisfactory response to this question, right? Frank Pasquale, also in this book, The Black Box Society, he speaks at large about these things, like about how like there are many layers of opacity in these algorithms, legal layers, technical layers, societal layers in these algorithms that prevent us from ranking. And I think transparency in ranking is very important because of many reasons, but I think this is a very good one. And it says, like, if you go to a large demonstration today and you see that television doesn't show it, then you can claim that the TV is biased against this demonstration and is hiding the truth. However, if you don't see this demonstration in your Facebook newsfeed, then how can you claim that you don't know if that happened to you or if that happened to everyone? So it's not, there is no transparency. There is no way to know whether they are promoting liberal media or Republican media or conspiracy theories and so on, right? So there are a couple of approaches that have been proposed for transparency. One is this idea of nutritional labels. So nutritional labels show you like the ingredients, the components, the characteristics of food. And in this case, they show you these elements for rankings. They show you if the ranking has passed or not a certain test, what are the elements of the ranking, and so on. And there are other proposals like perturbation-based methods for transparency in ranking that basically tells you which feature you will have to change in order to alter the ranking, which is not necessarily the feature that weights the more in the ranking, right? So you may have a feature that is very heavy for the purposes of ranking, but every element in this list has that feature at a high value, for instance, and there is some other feature that is not among the strongest one overall, but for this particular ranking, a small perturbations on that feature may lead to changes in the ranking. And that provides you something actionable to do, right? So in the case, coming back to the case of business success and business search engine, you may have something like, what's hurting you is that you need like a 4.5 star review to get to the next level in this ranking, right? Or you need to provide a phone number. There are other elements that if you change them, you will go up the ranking. Transparency can help us to avoid sneaking affirmative action in places where it's not welcome, because this requires a broader discussion. And we need to also like make sure that sometimes we can end up certifying that an algorithm passes certain tests but is part of an unfair system, right? Or is using conditions of unfairness. So to conclude, I would say that fairness in information retrieval and recommender systems have been less studied than in machine learning and data mining. This is, I would say, historically, it started in data mining, has moved to machine learning, and is now a concern of information retrieval and recommender system. Sometimes studying algorithmic fairness requires solving an algorithmic puzzle. Sometimes it requires to look at the context, right? And we need to make sure that we understand what are we trying to solve. Are we trying to remove discrimination, or are we trying to provide equal opportunity? And I think I will stop here. Thank you.
Perfect. Thank you very much. That was a tour de force there of information, and I'm so glad this is being recorded, because I want to go back over this talk. Colleagues, if you want to put some questions in the chat, I'm happy to paraphrase them. And in fact, if you want, I can call you out and then you can unmute. A question from me, though. I mean, I was just thinking about that Trump comment. I mean, the challenge with the Trump comment is, I was reading an article the other day about fairness in news, and actually someone was saying on an article I read that actually what is the right version of news? I suppose that's kind of or what is the right mix of news? And I suppose that's your comment in a way, whereas we can fairly easily say men and women should be treated equally. It's not at all clear what the right mix of news output is for, with a news search engine, I guess is the problem, right?
Right. So, but nothing forbids you, from having a communist newspaper or having a right-wing newspaper. I think I don't know completely the legal framework, but I think one very obvious legal obligation is that the property, like who is the owner of a newspaper, should be known. right? And perhaps it should be, and journalists in this newspaper should be able to speak up and say, well, I was hired to work in this communist newspaper, but actually my boss told me that I should publish right-wing news and that we are promoting to this communist audience, or I don't know, whatever, right? So I think the issue is more about like learning about having some external certification of the internals of your processes, right? So even like you have that for hiring processes, right? So you have in a large institution, you can hire an external company to review your hiring processes and certify them as non-discriminatory or compliance to the law, right? You can hire an external company to audit your finances and ensure that there is nothing that is illegal and that nobody is stealing, right, internally, right? And you can have these external audits. They are bound by confidentiality, and I think one can have a similar setup for algorithms. And you can have an external organization that is hired to audit an algorithm or audit a process. And in this case, to certify, okay, Google News is claiming that they don't editorially intervene with the ordering. Okay, so let's have an external company certify that, and that's it. Like now, if that doesn't prevent them from having a bias or another or whatnot, like if they disclose it, right?
Okay, so it's about the transparency of the algorithm. I mean, I was thinking in terms of, you know, if you're talking about discrimination, as you did earlier, you could say, you know, you could allow some people who are traditionally discriminated into a university, and if you discover that actually they do just as well as people who would have got a higher score in the entrance exams, it tells you very quickly that you've actually got a problem. With news, if you decide to show only, for example, a very central set of newspapers, New York Times, CNN, maybe Fox News, and you sort of, it's very hard to know whether that is a better approach than showing a huge diversity of content, including lots of fake news. It might take several years to actually decide whether that's good or bad for your society.
Exactly. Yeah. Okay, now I understand you. Yes. It's a much larger issue. Yes.
Paul Thomas, do you want to unmute and chip in your thoughts on this?
What thoughts you have, Mark? I have thoughts aplenty.
Tell us your thoughts about transparency in Australia.
I was just noting that that I think the ACCC is driving it. There's a proposed enforceable code. This is not yet legislated, but maybe, which will require, amongst other things, I think maybe just Google and Facebook. I mean, it's companies of a certain size, which may be Google and Facebook, who abstract and present news. So provide news in your feed or news search to expose some of the workings of their rankers to the news agencies they are abstracting. I'm not a lawyer. I've no idea how this will work, but it'll be interesting to see if it gets up, just how that pans out.
It's a requirement of disclosure, or is a requirement of certification?
It's I think at the moment both the large digital companies and the competition regulator have ambit claims, right? So that if anything is decided and enforceable, it'll land somewhere in the middle. I believe the proposed code is not for certification; it's for transparency to a degree to a number of publishers.
Yeah. So
how it pans out, we'll have to see.
Yes, I presume you're not getting this on your feed, Carlos, but for us using Google search or YouTube right now, we get a whole bunch of little pop-up messages from Google warning us about, presumably this is the same thing, Paul, right? Warning us about these Australian laws.
Yeah, Google have a real bee in their bonnet about it. Yeah.
Yeah, Google's very unhappy about this this planned thing that's coming, but. So there was a discussion. There was a side chat of people trying to find good examples of autocomplete that hadn't been blocked yet, and there was one point actually Paul Thomas made it in the chat which was I'm not that I'm trying to characterize Paul Thomas as a pure free speecher, but just kind of, I suppose, questions, particularly in the autocomplete blocking. I mean, I think everyone in this audience, of which there were about 70, by the way, so thank you so much for your talk, would I presume support the idea of blocking, of the kinds of autocomplete blocks that Google has done. It certainly is a blocking of some level of speech, and I wonder whether that's something that's been discussed in the literature.
Right, like this, the relationship of this to censorship.
Yes.
Right? Yes. No, I haven't seen. No, I haven't seen that discussed. I will say the majority. I mean, the work I can remember out of the top of my head speaks about sexism. I would say mostly, and about the stereotypes of like racial stereotypes and national stereotypes. But I don't remember a discussion about whether this impinges upon rights of, let's say, free speech for the people who are doing this.
Fair enough. Okay.
Yeah.
No, but thank you. We've got time for one more question if someone's got one? Whoa. Okay, Ahmed, do you want to unmute and ask your question?
Sure. Thanks again, Chato, for the interesting talk. This problem always gives me a hard time to understand what is the line between trying to correct this bias without affecting the objective. So, for example, here you mentioned in the slides, we have to differentiate between eliminating discrimination versus providing equal opportunities. So, for example, if you have two candidates that have the same score based on some criteria, so let's say the job search example, in terms of qualifications and stuff like that, regardless of the how they wrote the document or the source of this bias. But if someone is privileged with education, they will tend to be better at it. And if this is happening over an extended period of time, most of the time they will have higher qualifications because they have an advantage. The rich gets richer, right? So how do you draw this line? Is it individual based on each system and what are their priorities? So, for example, for government, they might enforce even if they have two different types, one of them with less qualifications, but they want to promote the balance between those two groups on the long term. So they might favor that person versus no, they are after the best qualifications regardless of the gender, for example.
Yeah, so this is a very difficult discussion. I will point to this book by John Romer called Equality of Opportunities. In short, I would say what he describes there is that first, that in many cases these affirmative action or positive action programs that try to address provide equal opportunity are temporary, and they are instituted for a limited time, and they are reviewed, right? So in this case, they are instituted when there is a big disparity between two groups, and they are instituted for a short amount of time. Second, also Romer in his book, he says, well, there are many opportunities to correct these disadvantages. And what he claims is that the last opportunity in which it's morally justifiable, according to his reasoning, according to his moral reasoning, is in university admission. So after university admission, there will be no justification, for instance, for hiring a candidate from a minority that provides less utility or will have at work or whatever. Like they would say, first, you don't have such objective measures of utility at work that as you have in a university, and second, perhaps at that point it's too late, and at some point you have to kind of stop, right? I said, ideally, this should be applied the earliest. These corrections in society should be applied as early as possible. And the last point in which he, in his book, justifies applying these corrections is in university admission. So that would be my answer. Like, first, these measures are temporary. They are applied on cases that are very clear, in which a group is very clearly disadvantaged, and ideally they should be applied earlier rather than late, and maybe the latest is the university admission.
Thank you.
Thanks, Ahmed.
Okay, so we're at time, and I just want to thank you, Chato, so much for making the time and dialing in and connecting with us. This is Barla's been inviting a whole bunch of people, and I can tell you that you've broken the record of people that have turned up to talk. So I think if you can imagine a room with 70 people watching you, that's what we managed today, and it was, you know, it's a fascinating and critically important topic, but the coverage that you provided was just astonishing, and I really cannot thank you enough for giving that talk. I believe that there's going to be a follow-up chat session that Barla has set up with a few people. I think that's on a separate invite link. So those of you who know the secret separate link, I invite you to click on those. But for those of you who are here for the talk, thank you for the discussion, and thank you for your attending. And once again, Chato, thank you very much. That was a fantastic talk. Thank you.
Thanks for the invite, and it's great to be among friends. Like Alistar was in my PhD committee, Barla was my colleague in Barcelona, Ahmed was my colleague in Qatar. So it's I feel very welcome. Thank you very much.
Thank you. We need a clap button on these darn machines, but anyway, okay. So thank you. I will sign off, and as I said, some people will see you in the follow-up chat. Okay, thank you again.